I'm Valērija. I'm from Latvia, work for Latvian Environment Geology and Meteorology Center as aviation forecaster. As well, I can work as a general and marine forecaster. And my second duty is operational work coordinator. Today we will look into our new hydrometeorological warning system, which we will introduce this year. We already have some changes in previous years, but this big change will be this year. So I will speak about that today. And here's a little bit intro on what we will talk about. So the project goals, what we had before 2024, what is our new concept of our warning system, as well what we have in the future for us. So a little bit short information about how forecasters work here in Latvia. So daily we have one forecaster. It's 2 shifts, one day shift, one night shift. And this forecaster, he covers general and marine forecasts. As he's writing a forecast, he's also doing this data editing, which is still done in Latvia. Also, all communication with social media is also on this person, as well as warning issue. So all is covered by one person. And I think it's 2020, 2021 when we started the project. This project is a small part of the bigger project from Norway grant, and our project part include this main goal to improve our early warning system for dangerous hydrometeorological conditions. And here you also have listed a few main results, outcomes which we want to achieve. So we want to revise existing and define new hydrometeorological criteria. We want to design for us impact assessment concept. As well, we want to update warning visualization system. And also, till this year, we didn't have good cooperation with local governments, third parties for impact assessment. And also on the regional, on the local level, and that's the one result which we want to achieve. And also we want to make some informational study thing for public society to educate them for about our new warning system. So that was our main project goals. Yes, so here is a few activities, the scheme of activities. On the 21st, we start to analyze climatic data, extreme events, develop our warning criteria for several meteorological and hydrological phenomena. Then in this same year, we also start to think about this impact assessment concept. Also, we try to develop this concept. Next year, so we try to build something similar to hydrometeorological impact database. So we gathered third parties' data, analyze them together, and put them together to make this kind of database, if you can define it like that. And starting in the last year, we started to design the operational tool for forecasters to prepare and distribute the warnings. So the process will be easier and more understandable, because it's completely new concept for us. Before that, we have a different kind of thinking for warnings. And also in the same years, also this year we will continue to do that. And also we are adding one point that we need to make this warning effectiveness evaluation system to evaluate how our operational tool works, how this impact assessment is working, if it's fine, should we improve it, and that's the big goal for this year. And also, this year we are planning to update our warning web page. And during this years, we also have a few exchange of experience, also seminars with Met Norway, FMI, and EMO. So we have successful communication with them. So that was a nice experience. in this field. And next thing what I want to tell is about our previous warning system. So if we can divide its 2024 before and after. Before we had these warnings prepared based on thresholds. We had like a certain general information about these recommendations, what kind of impact, but this was like a really short note about that. Warnings was in a CAP format, and also we had visualizations on the map from large historical regions and to municipalities. Forecasters can choose different kind of polygon. We started doing that in 2021 when we changed our warning preparedness process. So if we can tell it like that. And it's here's the scheme how warning distribution worked before. So the first one, we issued warnings for society and State Fire and Rescue Service and on different services, which includes also like ministries and kind of like departments like that. And this other part is warnings for clients, which is not publicly available. And there's a thing that we issued warnings. We sent them to Meteor Alarm. We sent them to state TV and radio, to social media. But it's like small information, what will happen, what kind of weather, what will be impacted, but really short note about impact. So just when, what, and what we can expect in short form. Also on the left, on the right side, you can see how this visualization looked in our web page. A little bit cluttered when we have a few weather phenomena going at once. So yeah, we want to also improve that kind of visualization. And here is a weather phenomena which we warn, hydrological and meteorological. Also, one goal of the project was to introduce 4 new warning types. I will speak about them a little bit later. So yeah, we have a variety of the warnings. They're different. So starting from storm surge and ending with some cold spells and frosts. Okay, so the problem why we need to make a new operational tool is that now a forecaster lives in 3 different systems, if I can name them like that. So the first system is where he is choosing what will happen, time of this event. He write the text, what is expected and when. Then we have the second tool. It's a SmartMet alert system. And here he can choose whatever phenomena, whatever threshold, he can draw the territory. He can choose, for example, some administratively already prepared territories. And then we need somehow to combine this text forecast from here with this pictures like glue together to publish and send them to Meteor Alarm or our webpage. So then we have this third page. When we glue them together, then we are sending them. And here how it looks in our webpage. There's when you like pushed on this warning, there's information about time, about the phenomena, what is expected, and in the bottom there is information about the impact, like be aware, be prepared, like standardized information. So, and here is how it looks when we are sending to our search state fire and rescue services and also for ministries and different organizations who deals with consequences. So here is what also expected, what level. So we are highlighting them. If it's yellow, orange, or red, and etc. And there on the bottom part also there is information about the impact. So a little short note. The new concept which we designed for us is that we don't want completely remove the threshold information because it somehow helps forecasters catch the event. So the first we want to base our warning on forecast, like this sport criteria, which used to be like thresholds, then combine them together with the probability, and then we will add this impact information and other factors, which will in the end make our final warning, which will then send to State Fire Rescue Service and Emergency Medical Service and different another services, then municipalities, our web page for warnings, and for public broadcasting. So this little scheme shows a little bit about what we are thinking on issuing this impact-based warnings in Latvia. And the next, I'm dividing the presentation into two parts when I'm speaking about how we analyze this historical hydrometeorological data, and the second part when we analyze the third party's data. So the first part is about this historical data. We have different type of analysis. So for example, I will show you a few examples. Here you can see that for floods we use return periods, for example. For warnings we use recurrence rates, and in the both charts, in the upper chart you can see the number of precipitation events according to the warning criteria in each year for Riga, starting from 2005 till 2022. It's interesting that red warning we introduced it only in 2019. Before that we have only yellow and orange, but if we are looking back then we can see that a few times the red warning threshold was reached. So this return period is corresponding pretty good with our existing thresholds. And also on the upper chart, you can see the number of cold spell warnings which we prepared and issued starting from 2013 till 2022. And you can see that in this time period is like 10 years or something. We haven't issued any red warning for cold spell, only yellow and orange in the last. So this information was gathered till 2021, if I'm not wrong. So in 2020 and 2021, there was also a few orange warnings. Okay. Also, type of information analysis we made included analysis when we tried to merge few meteorological parameters and find some correlation between them. The one was about the thunderstorm activity, because previously we had the threshold for warnings which included inside not only lightnings but also wind gusts, rain showers, and hail. So here you can see on this left side there is analysis for selected events, so how lightning strikes, wind gusts, and maximum 3-hour precipitation amount correlate. And on the right side here you can see our country with our station network, which is divided in cells 10 by 10, and the color corresponds to the highest number of lightning discharge from all events in one cell. And this event is defined when the first lightning discharge is observed, and ends when the last discharge is observed, and there is no discharge after in 3 hours. And you can see that from this right picture that there could be more than 400 lightning strikes, but for example on the left side the maximum lightning points, which is a red points, it's less than 400. It's so because when we analyze the data, we choose the case when we had information from station also for the gusts and from rain showers. Not all cases with high lightning amount had information about some severe wind gusts or severe rain showers. So that was this methodology to select these cases for this study. And also colleagues who studied this thunderstorm activities and that stuff, they made like conclusion that there is no like how to tell like So we can't tell if there is a correlation between these lightnings and rain showers and wind gusts, because all cases are different. In some cases, there could be a small amount of lightning, but the severe gusts, or vice versa. So in our case, we didn't find any correlation between these three meteorological parameters. Here also in the next slide, we want to introduce new warning. It's a frost, so we analyzed also the vegetation period in Latvia. So here's one picture on the left side of this analysis which we made. So we analyzed this vegetation periods by day in each meteorological station, almost each, I think, from 1961 till 2010. And the one big thing which also was made, it's on hydrology. We analyzed returning periods. In this graph on the right, you can see observed annual maximum water levels in rivers like Daugava, Aivīkste, and Lielapa, starting from 1904 till 2020. So there is also a big job done in that field. Okay, that about this historical information analyzed. There was much more in that, but here's a few cases. The next one is about impact assessment, how we approached that. We have meetings. We messaged many companies, many services about this opportunity to join us and help us to assess this impact. We managed to we managed to get this work together with the State Fire Rescue Service, Energy Sector, State Emergency Medical Service of Latvia, Road Safety Directorate, which is not road maintainer, and Latvian State Force. So this is the 5 big companies, organizations who joined us in this project. All this data was in different kind of formats, so there was a big job done to put them together so we can somehow analyze them at what point. So all information was different in time and space. So yeah, there was a big time and job done in that field to organize all that. And the one pity is that insurance companies and road authorities, they declined the option to join this project. So we will hope maybe in the future when they will see the results of the project, they want to join us and share with their data. So it's the goal for the future. Okay, and next I will show a few examples how we analyze this data. The first one is we analyzed this information which we received from emergency medical service. It contained different causes of calls. So it starts from like heat and light effect and ends with a heart stroke or the injury someone gets when they fall or something like that. So we divided this causes, and then we analyze together with different kind of meteorological phenomena. Here you can see how many calls per 1,000 cases was with heat and light effect, depending on the hourly average air temperature. And here you can see that there is a big rise starting from something 30.5 Celsius degree temperature. So we can see that on that point there is a high level of medical problem, so that this authority, you get many calls at that temperature. So the next one here also is yes, here we also analyzed also these calls with the reason heat and light effect, but we checked how many consequent days was more or 27 degrees was reached. So, and also you can see that after second day, this amount of calls, it's increased. So this was done because before that, And also now we have this warning criteria, which includes that this temperature should reach 2 days and more then we will issue the warning. So if it's like just 1 day, 27 or something degrees, we are not issuing if we know that the next day it will be around 23 or something degrees. So the impact will not be so high when it's like few days and more. Next example is about how we analyze information for our state fire rescue service. It's organization who get the calls about the fires, about if some trees are broke down or something happens, so they need to like this debris to clean up and deal with the consequences of the wind gusts and etc. So in this chart, you can see the calls which this organization got by maximum wind gust by season. And here you can see, like in the first picture, A picture, it's a winter time. In the B picture, it's a spring. In the C, it's a summer. And the D, it's autumn. And here you can see that in the summertime, which is C picture, when it's 14 meters per second, there is a higher amount of calls than when it's winter or spring or autumn. So we need to think about that, that in the summertime, there is a bigger higher amount of calls with the lesser, with the weaker wind gusts. The next one is example which we took from our road maintenance authority. So here you can see the average number of accidents per day, and in this information they include what kind of weather was observed, but we need to keep in mind that this weather which was observed, it written down by not meteorologists, so it could be like long-lasting rain, not only shower rain. This information is from Riga from 2015 till 2020, and we can see that we have a higher amount of these accidents, car accidents happening in springtime, in March, in February and April, and the lesser is on the end of the year. So we can also think about the criteria, how we can change them by seasons, looking at this kind of information. And the next one is we analyzed the freezing rain and freezing drizzle accidents, and this kind of warning is important not only for society but also for energy sector, because they have a problems then with these wires with power outrage. So we try to analyze this outbreak number of power line breaks considering this rainfall and air temperature. So we can see at what temperature and what precipitation amount there is a bigger amount of this breaks. As well, here you can see that there is also a big break number when it's higher temperatures, but in this case we looked more for freezing precipitation to have this range of the temperature from what minus 2.5 or something till plus 2.5, that in this temperature there is higher risk of this power line breaks. Okay, and one more example also, it goes together with our new warning, which we will introduce this spring. It's grass fire risk. So here we analyze together the snow cover with our state fire rescue service calls starting from 2020 till 2022 season. It's just 3 years spring seasons, because this state fire and rescue service, they started to send our information daily from 2020 May or something. So we have only for last 3 years this information, but nevertheless we have the correlation from this chart. You can see that green numbers, they show days in a decade without observed precipitation. Red numbers is the maximum number of the consequent dry days achieved in this decade. Blue numbers, they show the total numbers of the calls which received this organization. And red line show the snow cover. And the black line, percentage of the grass fire calls from all calls. So you can see that when the snow cover is melted, then this grass fire risk goes up. Also, there's a correlation between these dry days and when the dry days are consequent. So we have a big problem in our country when it's spring. Many of our peoples they burn this fire grass to clean the fields. So, and then there is bigger risk to have this also forest fires, and a big job is done by our state fire and rescue service. So this kind of not forecast but warning will be sent only to this organization, because in the opposite way, if we will like warn people that there is a good condition for this grass fire, then they will do that. They will not like, oh no, we will not burn the grass. There will be an opposite effect of that. Okay, so that was a few examples about how we analyze the third parties data and climate data. And as I mentioned in this one of the first themes, that not only this support criteria and third parties data will affect the warning level, but there will be also other factors. For example, what kind of the day it is, if it's Sunday or Monday, how we have some mass events, some festivals, or city fest or something. Also standardized precipitation index and etc. All this information forecasters and in information analytics, they include it in the charts. For each phenomena, they added this plus minus index. For example, if it's in this criteria increase or decrease the impact. For example, if it's a Friday and it's a morning, we have a bigger traffic. So if it's snow or rain event, it could impact, it have a bigger impact than if it's, for example, Saturday or Sunday morning, when a bigger part of people are home and they're not on the outside. So this is kind of approach we used in this chart. Also, it includes the probabilities for models, and for each phenomenon, this chart is a little bit different. Also, we introduced the green type of warning if it will not be officially sent to public, but if it will signalize forecaster that there's happening something, that they need to check it, maybe to upgrade it to yellow. Because, for example, in our country, we need to install the winter tires for cars starting from 1st of December, and then till end of February. And during these 3 months, we need to have these winter tires. But as we know, in this territory here in the north, we can have snow also in October and November. So it's not excluded that we will have our 5 or something centimeters of snow in the November, when the part of cars don't have these winter tires. So it can increase also the impact, cause the impact. And sometimes maybe we don't need to reach exact threshold to upgrade this warning to higher level. So yeah, and here are general changes in our warnings, warning support criteria, as we are calling them now. Yeah, as I mentioned, we will use this input information, but we are not putting the thresholds aside. And the main change is that we separated the wind warning. We separate the coastal criteria from inland thresholds. This one big change was also for snow. We increased the threshold for the red warning, and also we combined together snow, blizzard, and icing of the wet snow together. Before that, we have 3 different different warnings, and there was a problem. Well, when all the three things occurred, we have overcluttering. So now blizzard and icing of the wet snow, they will work as impact increase factor for the snow event. So something like that, they will cooperate together. And we implemented this type of warning in December, and we are using for this winter. For now, it's going good. And also we have some feedback from road authorities and another sectors. Also, we separated the summer and winter thresholds for lasting rain. It was done because of this analyze about the soil, how it can accept the moisture, the water during the winter, during the summer. So it was done because of that. Then the heat warning thresholds, we changed them and implemented already in the summer 2023. It was the second change of this heat threshold. The first try to implement was in 2022. Then we have a little bit different thresholds. We have some issues with these thresholds, but then we learned our lesson and changed in 2023. And after the summer, we can see that this thresholds works really well for us. And also we have new thresholds for thunderstorms and completely new thresholds for fog. So there is a few minor changes in different thresholds, but this is the main for our support criteria. And for now, this operational tool, as I mentioned before, it's still in design process. It's still not done. So the forecasters can't use it fully. And to keep the decision tree, we are using like this chart when we have all cases. So for example, here you can see the heat cases from the summer. They put the day, what kind of temperature was expected, how many consequent days in a row it was, what kind of probabilities, I don't know how high was this field temperature, if I'm not wrong, it's called like that. So, and all information which impacted this result of this level, and also they can put some brief comment why they decide to do so. So all this information is gathered, and then we can evaluate the warnings. Same is for the snow warnings, which we introduced in December. So we are using this kind of system for now, before we don't have we don't have this operational tool for now, so we are using this chart. So we have some information from the past. I mentioned that we want to introduce the 4 warnings, 4 or 5, something like that, if I'm not wrong. The one I mentioned already was the risk of the grass fires, which will be sent only for state fire and rescue service. The second one is a frost. It's this warning mainly from last year. We had the really cold and dry May and June, so there was a big damage to our crops. So there is a need in this kind of warning. It's not only last year, also before that, society and also agricultural workers, they asked for that kind of warning. So we made the methodology for that, and we plan to start issue that from this spring. Also, we will have some kind of warning, if I can tell it. It will be like for UV radiation. So we will have only yellow and orange warnings. So because it's also important here, because many of our bigger part of society, they have a pale skin, they can't prepare for this UV radiation. And it's good for them to know what kind of indexes we have at the moment, so they can somehow to make safe themselves, so to put some sunscreens or something, or even don't go outside. And then the one big thing which was done was new hydrology criteria. We have completely new thresholds for around 79 stations, if I'm not wrong. This thresholds was implemented and used already from 2022. Before that, we have only strictly defined this criteria for storm surges for 3 cities. It's coastal cities, Riga, Ventspils, and Liepāja. And only 4 hydrological stations had this strict thresholds. Others had this old criteria for yellow level floodplain inundation. And I think we have success with this new thresholds because January and February of 2023 was a harsh time for hydrology in Latvia. We have red warnings. There is a big floods happening in pretty big city, Jēkabpils. There was evacuation, closed roads. They even closed the bridges. So this criteria, they showed really good in that situation. And the second big thing for hydrology, we introduced the hydrological drought, also completely new warning type. And this warning type is based on return periods of water flow. So like that. And here are completed tasks during these 3 years. So we have methodology for this new warning criteria and data analysis. Also, we have impact assessment guidelines for forecasters. We have held the training seminars for forecasters. We will also have one this month in the end of February. One more. And also we have introduced a common briefing with civil protection authorities and other services from this year, February, once in a week. So this is a big achievement for us because before that we haven't such communication before, even when it was like orange or red warning. So yeah, so it's a big goal achieved from our side. And a little bit about our new tool. Here is look how it looks now, but it's still developing. You need to keep in mind. And I want to show how approximately will look the way how forecaster is preparing. So you can choose on the left upper corner the phenomena. Then you can see in the chart, in the table, I mean, what time, what this threshold is expected it will reach. So you can check the table, or you can just click in this map and see in the map the territory. On the right side there is this active worksheet where you can see this territory which was not requested, but so based on thresholds. So you can see already the territory which is impacted based on thresholds. Then you can choose to draw the area which was recommended. And then choosing this area, you can also put this impact assessment. You just press the button. Before that, you can choose the timings or something. Then you press the button to analyze this impact assessment. And then, I didn't put this impact assessment here because it's still in development. Here it shows that there is a 0 impact, that there is no thresholds, not the threshold, but no impact reach. So there is no need to increase or decrease this warning criteria because now we are analyzing the cold spell, and for the week and so in the future we have like mainly positive temperature. There is no -20 or something. So, and also there is no criteria which shows we need to increase the impact. So after that we just use this send option. We can change the timings. Here you can see predefined text, so the forecasters don't need to write from the text. They have some kind of scratch, so they can maybe modify it, but they will save time when they have these templates as well. Here is not included, but in the upper corner on the right, right, they will be also this impact texts which forecasters can choose. They also will be pre-designed, but the forecaster also can add or change this text. It will not be like something strict, so they can maneuver in that. After this is done, they can send us a warning, and also in this tool, it's planned the forecasters can also change something in case, for example, they need to extend the warning timing, or they need to change something in the text. They can do that here. So it will all be done in one place. So we will not have these three systems which we have before. So, and what we have in the process now and our next steps, as I mentioned before, this development on the verification system, we want to save the value of our previous verification systems, which was based on criteria, but we also want to add this impact evaluation for the major events. Somehow we want to combine these two things together, not to lose this threshold evaluation, but also add this impact evaluation. Maybe it will be like one system with two separate evaluation things going on inside, but we will look for how we will manage that. Also, we need to finish this operation tool, which I showed you before. Then also society information and education, as it's something new for our country. We are migrating from this thresholds to impact, so we need to educate them what we will change, how they need to understand our warnings, and also the big goal for us is to develop the warning app. We have the web page, it's working also for the phone, but it's better to have the app which will also send some notification to users. So yeah, that's the future for us. And I think I'm done and I'm ready for questions. It's in the Latvian, so if it's possible, I can zoom in. But so the point is that here you can see the thresholds for example, this is thunderstorms, every thresholds, and they are going down, 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 but their impact. Then here is this time and month scale, which we have the higher impact. For example, if this event will occur in the May or in the September, for example, or in the morning, depending. As well, here you can see some meteorological phenomena like hail or showers or gusts, and here is the probabilities of the event, and also here is SPI, which is standardized precipitation index, and which of this values, not values, but criteria or factors, how we will call them, is given this index. It's 0, +1, or -1. So, but for each phenomena, it's different. So it was done manually by forecasters after they have done this historical data analysis, third parties data analysis. They saw some correlation in the data, also the literature review. After all that was done, they put this in this chart together. I think I hope I answered the question, or it was not a question.
Yeah.
Okay. Good evening. I'm Abebe from Niger Republic in West Africa, working with ASECNA. I want to know regarding the warnings. Do you issue warnings for icing and turbulence? If yes, what is the indices you're using?
So you mean aviation?
Yes.
It's a separate department. As I work also as an aviation forecaster, it's a separate warnings we issue for turbulence and icing, but it's not in this project. This warnings is for general and marine forecasts. Yes, forecaster can choose different region. They can even put like 1 per 1 kilometer point and just send it. So it's free to choose. Also, they can choose by these administrative regions if they want. For example, we use that for hydrology warnings at some point. It's more convenient, but forecasters usually draw something new because it's hard to not always meteorological phenomena happens in one administrative region. It's can like a thunderstorm. It can be in between of 2 administrative regions, so it's easier to draw by themselves.
Are the warnings only communicated in form of graphical surfaces, or do you also communicate them in a textual way? I mean, if you have free areas, it's more complicated to describe them if you have to assign them to given areas.
It's both. We have this graphical, and also we have a text. Where is the picture? Let me show you. It's like that. So here you have this graphical image, and when you are pushing this territory, you have this textual. Everything is here by what is expected, what kind of impact. It's like an old version. In the new version, we will have more this impact information, not the much of the threshold information. So everything is here. Also, in the future, we want to provide more information from these authorities who are dealing with consequences, like this medical services or fire and rescue services, because they know better what kind of advice to give. So we will cooperate with them in that point.
But how do you send them this information to the authorities, for example, if you don't have given areas where you can assign the warning to? So you have to distribute them to the whole country every time? Or
once again,
how does it? When you, I think that some recipients want to get only the warnings which they are concerned by, and if you don't fix some regions, you have to do it in another way. How do you assign and distribute the warnings?
If I'm understanding the question correctly, the authorities who want to have this specific region or something, they have this like a document they have. For example, if it's some specific region which have floods, they receive the document.
So you assign the free areas to given regions.
Yes.
You have fixed regions underneath it.
Yes.
So to say. Okay.
Yeah,
so you map the free area to fixed regions.
So here is how it looks. It's the old administrative reform. We have now the bigger regions, not so many small ones, but they are assigned under. Now it's a little bit hard for me to remember if my colleagues Laura or Anastasia, which are closer to work computers with this information, could check and answer if it's possible, because I'm not keeping all the criteria in my head for today. Sorry. I hope Laura is here.
We can take it on. We can take it on email. That's okay.
Yeah, we can do that on email. Yeah. No. Because we try to get any information we can, and for each organization it's different. For example, I mentioned that we have this communication cooperation with State Fire Rescue Service from 2020, and they are sending our information daily. We are receiving each morning information about the previous day and night. For example, for this electricity provider, they provided us 10-year information. For this also health authority, same. For forestry, also around that. For road authorities, it depends on this seasons. For example, I think it was something around 7 years, but mainly around 10 years. But we didn't ask for a certain year of information, we asked for future cooperation, because it's something we can try to use and analyze this information, and if they agree to share, they can also share in the future, and we can grow this database, this length of this information, and then make a reanalyze. Also in the future, we plan make the reanalyze of this information maybe once in a year, or once in a 2-3 years, something like that. So there was no like harsh like criteria for years. And about the weight, yeah, that was also the question that we technically we need to be prepared. We also like added more space, if I'm correct, to our servers, expanding them so we can store this information, because every organization send different type of files, and in the process we need somehow to remake them and put it under one kind of information. For example, it could be PDF file, or it's XLS file, which is easier to use. It depends. And also one thing which we are doing, we are storing information from social media like X. We have a script which gather all information related to this hashtags which we gave our IT guy who made the script, and he's gathering this information for each day in the morning, so we can look in the future and check for this impact which happened if someone shared something and something, for example, was damaged or something. But yeah, we expanded our storage for this information. It's done already, but in the future we are not planning to keep it like that, because it will be integrated in this operational tool. But we want to keep a place for the comments, so the forecaster can leave some notes why they decide to do that. And when we will analyze and verify the warning, we can also see what the forecaster was thinking and what was happening at that moment, because the verification can happen in a few months after the event, for example, and we don't remember everything. So we, at one point, we will keep this chart, but with a lesser amount of information, because the bigger part will be included in this operational work tool.
So does that mean that you fill in the table automatically in the production tool?
This information, which is here in the tool, but in the chart here, it's principally information which will be included in operational tool. Now forecaster just mentioned the factors which was reached. For example, what kind of the day, if it was a morning, if it was a high this field temperature, for the heat we are speaking. But in this operational tool, everything is inside in this chart, and then it's going in this operational tool. I hope I can understand it.
Yes, the question is, you have some parameters which you use to judge, to evaluate the impact.
Yes.
And I guess these parameters change from event to event. So
yes.
That has to be filled in somehow, and that can be done manually or automatically, or not? So
it will be automatically.
Okay.
Yeah, it's automatically. It will not be done manually. Forecaster will see the result and why this tool is recommending him to increase or decrease the level or issue yellow or orange warning. So he will see what is behind all that. And then he will decide if it's valid to use this recommendation or not. Yeah. No, we haven't took any extra people. Overall, there were how many? Around 4 or 5 forecasters, which also work in the duty, as well our head of department. We also have worked together with our climate department guys who analyzed for us the information, which was this historical and third parties data. So there was no extra person for this work, so we did it ourselves together with operational work. So yeah, it will be good that we will have some extra person, but it's good for us that we finished it ourselves as well.
Yes, if you can hear me, just a thumbs up. Yes, you interpreted it correctly. Yes, I was wondering if you have or are implementing any surveys or any ways of monitoring how your warnings are perceived or acted upon.
The good question. We are planning as well as to educate the society. We also want to have some feedback. So in the future, we also want some feedback from them. So we are planning some interaction as well. We have this yearly meetings with our clients or bigger organization when they give us our feedbacks. Also, we are sending them yearly surveys about our work, so they can also tell what's good, what's bad. Maybe we can plan in the future also do that with this warning things. One thing we have done, when we started to issue the snow warnings, we made also the calls in the first when we issued the first warnings for the snow events. We made a few calls for organization who deals with consequences like road authorities or this medical service and asked, was it good, was it not? So it was like a talking thing, but maybe in the future it will be good to have also some survey from that only related to warnings, not for all our work. So about the level of the warning. So the first one, which is it showed the level from this models. They are showing the threshold, which correspond to a certain level, and then this impact assessment is done, which shows should the forecaster should increase or decrease the level. And forecaster is the last point when this decision is accepted. He can decline or accept. So it's semi-automatical, semi-manual. So he have recommendation, but still he need to accept this decision. I think this will be easier when we will have an operational tool. For now, as it's a new concept for us, it's maybe a little bit hard because we are still learning. And this table fill, it's also a little bit hard when you have like big amount of work, but still it's done, and it's you can do that after you are issuing your warning. It's not like ASAP before the warning issued. You can keep that in your mind or put on the paper or scratch something to remember, and then you can fill it afterwards. So I think our forecasters, they are doing good. Also, when it's daytime, we have this assistant forecaster who can help with this task. So I think they are managing pretty good. And about this lead time, I don't understand the part about the lead time. Okay.
I think it means how many days or how long before the event do you issue the forecast?
How long before? It depends of the event. For example, if it's like cold spell or heat, we are trying to prepare them earlier. Or if it's like a big event, like orange or red warning for some storms or rain events, then maybe day 2 in advance. We have also this experience when we are starting with maybe smaller level like yellow or orange, and when it's going toward the event more closer, then we are upgrading. We are keeping maybe this level which we issued initially, or we are upgrading it up or down. But it depends. For example, for thunderstorms, we try not to issue so much in advance. It could be a few hours before event, but it's also depend if we are sure that there will be some red or orange event happening related to thunderstorm, we can prepare like day before. So that's really dependent on that. And how many times per day we are updating the warnings. It depends on how long the warning is valid. For example, if we have the warning for 24 hours, we can update the text, for example, like twice in a day. So it corresponds for the daytime or nighttime. But if we need to change territory, then it's completely new warning. So we are changing completely the warning. So it's not the same. So it's also depend on the situation. It could be like once a day. It could not happening. It could be a few times per this life of the warning. So for yellow warning, the forecaster can decide by themselves. Before that, for orange level, we had discussions going on together with our head of department or operational work coordinators or head of division. The same is for the red warning, but starting from this year, February, we also trying to make this briefings together with the authorities to decide together with them. We are trying to engage them. Before that, they didn't have so much enthusiasm in this field, so we will try to also add them in this decision tree, but before that, forecaster could decide if it will be orange or red, but also they can connect even if it's a night, day, Sunday, Saturday to head of department or operational work coordinator. So they are not the one who are choosing this level.
So either mention of probabilities in your warnings, like probability of level 2, level 3, and so forth.
So we assign a certain level of probability, like percentage for each threshold. For example, if it will reach this amount of precipitation, if it will reach this wind gust, for example, and the second part, which is not included in this operational tool, it's more probability if it's even possible. For example, if we can see the jumpiness in the forecast in the one ECNWF and Harmony model data, I can see that there will be something bad happening with the thunder showers in the last run. It's completely different. The cell is moved to the Estonia or Lithuania, so the forecaster need to analyze also that. So there is a two kind of like this probability, which is model probability, and like a probability if the model, how big the jumpiness is in the models. So no more questions. I shared my email, so in case you can contact me with the questions. So if I can, I will answer. So have a good day then.